what I mentioned is great. If you are new here, subscribe to my channel, hit on the bell button so that you will be the first person to receive any video I'm going to drop. Like, share, and drop your question on the comment section. Today we're going to look into advanced calculus. Advanced calculus. And under advanced calculus, we're going to talk about differential equations. Differential equation. DE as abbreviated. By definition, a differential equation is defined as the relationship between an independent variable x, a dependent variable y, and one or more derivative of y with respect to x. It's the relationship between an independent variable x, a dependent variable y, and one or more derivative of y with respect to x. So we have a dependent variable x, an independent variable y, and dy over the x, the square y over the x square. So any equation that contains any of these, we can easily have other higher derivative, the cube y over the x cube. So any equation that contains x, y, and any of these, it can be two of them, it can be three of them, it can be one of them, but it must contain x and y and contains any of these are derivative of y with respect to x. So any equation that contains, let's take example, you can have e.g. the square y, dy over the x plus 4y is equal to 0 is example of a differential equation. Another example, we can have the square y over the x square minus 4 dy over the x plus 6y is equal to 0. This is also a differential equation. We can equally present it this way: y double prime minus 2y prime plus 7y is equal to 0. This is equally a differential equation where y prime is the same thing as d square y over the x square. Y prime, that's the first prime of y, means dy over the x, which is the first derivative. Okay, we can equally have other example: d square y over d squared z over d x squared minus 3 dz over dy equal to 0. This is also a differential equation, though it's a partial differential equation, but we are going to talk about that in the next. So now let's talk about having known definition of differential equation and some example of a differential equation. Let's talk about types of differential equation. DE, types of differential equation. Of course, we have the ordinary. We have the ordinary differential equation. Ordinary DE, ordinary differential equation, that's called ODE as abbreviated. Okay, by definition, this is a differential equation involving the derivative with respect to a single independent variable. This is it is involving the derivative with respect to a single independent variable. Ordinary differential equation is the differentiation is a differential equation involving the derivative with respect to a single independent variable. That's ordinary differential equation. It is denoted by dy over dx. Then the second one is partial differential equation, partial PDE. A partial differential equation is a differential equation involving the partial differentiation or partial derivative with respect to more than one independent variable. It is a differential equation involving the partial derivative with respect to more than one independent variable. Remember, ordinary differential equation is a differential equation involving the derivative with respect to a single independent variable. As you can see, let's see example. That's what's noted by this. You can see the single independent variable is always with respect to x alone, and I'll give an example after this definition. So we already talked about partial differentiation as the differential equation involving the partial derivative with respect to more than one independent variable. The example will tell us what we mean by being with respect to more than one independent variable. Okay. It is denoted by partial differentiation of z with respect to x. That's how it is. Let's denote that. So let's say x. The example. Examples. Let's detect or let's identify the partial differentiation and the partial differential equation and ordinary differential equation from the examples I'm going to show now. So the square y over dx squared plus 2 dy over dx plus 3y equals 0. This is an ordinary differential equation because the independent variable under is just the same. This is x and this is also x. When we have two different independent variables, we talk about partial differential equation. Watch the examples I give at the beginning. If you watch here, you find out that we have two different independent variables. Yes? So this particular equation is a partial differential equation. You can even use this as an example. This guy here is ordinary differential equation because we have only x as the independent variable. This is also ordinary differential equation. This is also ordinary differential equation, but in this case it is partial differential equation. But our study in this section we're going to focus on ordinary differential equation. Okay, then the next thing we're going to look into now is not the formation of we're going to talk about the order and degree of a differential equation. That should be the next thing to talk about, the order and degree of a differential equation. Thank you and stay tuned.